Okay, this is 8.2b area. So we're talking about more ways to find the area of a couple things. Okay, so Huron's formula. When do we use this? So we use this. We have the lengths of 3 sides of a triangle. So that's when we're going to do this, okay? So we're using when we have the 3 lengths of the sides of our triangle. So Huron's formula is this. A is equal to the square root of S, we're going to talk about what S stands for in a minute, times S minus A, times S minus B, times S minus C. So it's the square root of all of that. Now, this is where A, B, and C are side lengths of a triangle, and S is called the semi-perimeter of the triangle. Now that has its own formula. So the semi-perimeter, that means that it's half, right? Semicircle half. So half of the full perimeter of the polygon. And to find that, we have that S is equal to 1/2 of A plus B plus C. Okay, so when we use this, all right, we're going to have to figure out the semi-perimeter first, and then we can use that for each of the S's that we have up in our area formula, okay? So keep in mind that A, B, and C are all side lengths of the triangle, and S is the semi-perimeter, okay? So we'll use this tomorrow in class. All right, so if we have an equilateral triangle, we know that we can, if we have the side lengths, right, which we would know, an equilateral triangle, all the sides are the same. And then we have, so we have Huron's formula to use. We also have the regular way, area equals base times height. And then we also can have another formula. So another formula, if it's equilateral, so all of these have to be congruent, we have another formula. So that formula is area is equal to the square root of 3 divided by 4 times S squared. Now I know that we're using S a lot, but we have to keep in mind what S means in these different situations. So S is the side length of the triangle. So if we were to use this, I could find the exact area if I had an equilateral triangle with side length of 6. I would say area is equal to square root of 3 divided by 4 times 6 squared. So area is equal to square root of 3 over 4 times 36, or 36 square root of 3 over 4. And then remember, we can always reduce. So if I reduce this, I would see that I would have, let's see, 4 goes into 36 9 times, square root of 3. And so if I knew this was 6 centimeters, it would be this centimeters squared. That would be my final answer. This only works, so it's super important that we recognize that this only works for an equilateral triangle. Okay, last but not least, we have to figure out a quick way to find the area of a triangle when you know the area and the radius, so this needs to go away, and the radius of the inscribed circle. So if I have a triangle like this, and I have a circle inscribed, I remember we've seen these before. If I know the radius, R, and I know the perimeter, this should say, excuse me, I'm so sorry, this should say perimeter. Okay, so to find the area of a triangle when you know the perimeter and know the radius of the inscribed circle. So if I know the whole perimeter here, okay, so A, B, C, right? So we know the 3 side lengths. We're going to use our semi-perimeter again. So this is A is equal to SR, where S is the semi-perimeter. And again, that means half of the whole perimeter. And R is your radius of the inscribed circle. So if I tell you that we have a triangle that's, I don't know, 5, 12, 13, make this up, with a radius of 4. So my semi-perimeter, we know, is 1/2 of 5 plus 12 plus 13. So that's what? S is equal to 1/2 of 30. So my semi-perimeter is 15. So the area of this would be my S, which is 15, times the R, which is 4. So the area would be 60. And if we knew this was inches, we'll say, then that would be 60 inches squared. Okay?